What the heck is up, everyone? It's Jacob here, and this is the final part of this series. I decided I just want to make it 3 videos. So in this video, we're going to primarily cover the software, just typing a little bit of code for it, and we'll do troubleshooting and just, ensuring that it works, and we'll test it and everything in the very end. But for the most part, this is going to be a screen capture, so I'm going to just have it screen captured. I'm going to test my new body mic. We'll see how that works. I'm probably just going to run it straight into my computer instead of recording to my cell phone. It'll probably just be easier because the screen capturing program, I think, will just take that input from the microphone. So I'll try that out, and then we'll go over here to the oscilloscope and the power supply and everything. We'll check it throughout the way as we progress through our code, just to ensure that it's working step by step, because you don't want to like type the entire code up and then test it in the very end, because it's very hard to troubleshoot it if something isn't working right. So that's how we're going to do it. We're going to go step by step. I don't know if I'm going to put the code actually in a link below the video. I don't really know, but it's very, very, very basic code. You could literally just copy it off the screen, and it's just a few lines. And I also want to make that disclaimer that I'm not like a professional software writer or anything by any means, and the code that we are writing here is very, it's very, very minimalistic. If you guys want to improve the code or modify it in any way you think it's, may improve it, I would encourage you to do so and post it, share it with others. But for the most part, we're just writing code that's good enough to get the charger working. In real life, you wouldn't use Arduino for this. We'd probably use, like I said, system interrupts and things that are very fast at responding to it, because you guys will see that we're gonna add some delays in here, and that can also delay when you unplug your car. It can delay the relay shutting off if your code is stuck in that part of when your microcontroller is looping through the code. It could get stuck in that part, that delay for that 1 second, and it could hold that relay open, that power relay open, for potentially a whole second as soon as you unplug your car. So I just want to let you guys know those things before we get into it. But the code will work. I will show it to you guys actually running, plugged into my car, charging my car. It will work, but I just want to let you guys know that's not bulletproof, okay? There are better ways to write the software. We are going to use some very, very basic control code. Alright guys, I don't even know how to explain this, but this is really embarrassing. I hate to do this to you guys, but good thing I shot these things out of sequence, because I already wrote the code and tested it to make sure it works. I was afraid this was going to happen. I knew I was going to do something stupid like this, but let me show you guys what happened. Okay, I'm in the middle of writing the software for this and troubleshooting it. Again, I've already wrote the software for this and wrote the code, but I wanted to do a video of the software as I'm writing it to show you guys the process of going through the code as you're writing it. So I'm not going to be able to do that anymore. I'm pretty much just going to give you guys a video of the code and explain how the code works and just show you guys what the code does. I really wanted to make a video of me going through the code as I write each bit and testing it on the board, but you guys are really going to have to take my word for it that this code that I'm writing works. I've already hooked this up, and I shot the sequence of videos earlier of it actually hooked up to my car and charging, so it does work with the exact code I'm showing you. I already wrote it, but I shot these videos out of sequence because it's nighttime now, and I'm doing all the software videos at night. But this is really bad. I was going to hook up the board, and everything looks good, right? Absolutely embarrassing. I can't believe I made this mistake. But I reversed the polarity on the board, so don't do that. The polarity is hooked up correct here, but I must have got a little excited, and I had my polarity reversed here, and I fire up my power supply, and poof, smoke just comes right out of the Arduino. So, and the voltage regulator is like cooked, all the chips are like smoked, that smell is in the air, and this is not a good time. But the good thing is I already got the board working, and I already tested it, and everything already works fine. So I have actual footage of this thing hooked up to my car in the garage, already working, and I already shot all those sequences, but I'm not going to be able to do like a comprehensive testing and troubleshooting video for the software. I'm just going to kind of show you guys all the software. I already have it written, so I probably will just scrap all the footage I just made and just show you guys the code and explain it. And if you guys have any questions about the code, I'll just do that. So I shit you not, I was in the middle of writing the software here. Again, like I said last night, I already wrote the code for it late last night. It was pretty late, and I was just working on that like all night. It didn't take that long, actually. It only took like an hour. But I already wrote the code yesterday and tested it, and it worked today. And I shot the sequences of the video. I shot the very end of the video first when it was daylight, and I had this code running on my car. This is on my laptop, and I had it hooked up to my car and everything, and it did work fine. But what I was trying to do is copy the code off of here and do it bit by bit on this screen and do a screen recording for you guys. And kind of after I write each segment of code, go over to the desk over there and show it to you guys, troubleshooting it. But I'm not going to be able to do that anymore because I really don't want to desolder that Arduino Nano off there. And I don't want to, put all new chips and everything on that board right now. That's going to be too much. I made it too close to the end to rebuild that entire board. But instead, what we're going to do is just go through all the code, and I'll explain it in great detail, hopefully so it makes sense. But, yeah, we're not going to have like a comprehensive troubleshooting, footage where I write a few lines of code, go over there, show you what happens, write a few more. That's not going to happen. Really sorry about that, guys. If it breaks your guys' hearts, I might make another video and do that again if I feel like desoldering that little Nano off the board, but as of now, that's not going on. And also, I'm almost finished, 94% finished uploading the first segment of this series. For some reason, when I render them, they turned out to be quite large file sizes. I'm going to have to use different render settings next time because my upload speed is very, very slow. It's like, 2 megabits per second or something. So uploading like a 10 gig file or whatever these things turn out to be is very long. It takes like almost an entire day. Actually, this thing's been going since last night, so it's been taking a while. So I just kind of wanted to give you guys that quick update in the process of filming this series. So without any further ado, let's just screw all this. Let's just look at the code and I will explain it in detail. Alright guys, what the heck is up? So this segment is shot after I fried the board. So I just want to tell you guys that this code that I have here, absolutely 100%, I promise you guys, does work. There are a few conditions that I will show you, especially going on down here, but it does work. In fact, this is the code. I just pulled it off a flash drive straight from my laptop, which in the end of this video, you will see it actually working on my car. This code is the exact code that I ran on my car, so I have not modified it in any way since. Like I said, I shot these segments out of order. So earlier today, I actually had the charger running. It's nighttime now, and this is the exact code that was running on my board earlier. So this is it. So I'm just going to kind of run through this real quick and explain it all. So first off, we just have all of our pin declarations here and variable declarations kind of out of order. This is not the cleanest code. I didn't really intend to present this code, but here we go. Here, these are all constant ints. These are our pin declarations, so we make pin variables. These are constants because they're not going to change at all. They will stay the same throughout our entire code. So the pilot pin, this is the pin that drives that LED on our opto-isolator. This is the pin, when we write this pin high, it will actually turn our pilot pin 12 volts on, okay? So this is pin 3 right here. And that is that LED opto-isolator pin. The charge request pin, this is the pin that actually checks if the car is requesting a charge. That voltage comparator that has that threshold set to 6.3 volts, the output of that comparator goes to pin 4. That's the charge request pin. The vehicle detect pin, this is what detects when the vehicle is actually plugged in. This is going to be the output of that comparator that has the voltage threshold set to 9.3 volts. So the comparator with the threshold of 9.3 volts, the output of that comparator goes to pin 5. And then we have our power relay. The power relay, this goes to the gate of that N-channel MOSFET, which drives our actual power relay. So that was on pin 12. When we write this pin high, it will actually turn our power relay in our charge controller on and give power to the car. And then I just want to explain these real quick. These are LEDs. I just named them generic LED1, LED2, and LED3. What they indicate, the first one just indicates power. So it indicates that we made it through all this setup code. Once the Arduino has successfully booted and it's set up, all of our setup code is going, right before the loop, it turns on this first LED, and that just indicates power and tells us that the Arduino successfully booted it into setup. LED2 tells when the car is actually connected, and LED3 tells when the car is charging. So this is LED2 is connected, LED is when the car is actually charging. Then we have two booleans. Booleans are just data types which have a true or false value. There's one for vehicle detected. We initialize it to false. They got very verbose names. So this variable is what it sounds like. When the vehicle is detected, we will say it's true. If the vehicle is not detected, then it's false. Same here with the charge requested. If the car is requesting a charge, we will turn this into true. If the car is not requesting a charge, it's false. By default, we initialize them to false. We want them to start out to be false. We don't want the charger to initialize with them being true, because then it will result in the charger turning on immediately as soon as the microcontroller is booted, which we don't want. Okay, so those are all of our initializations. So let's talk about the setup code, which is also kind of more initialization. First off, we just do a couple pin modes. So this actually isn't even really needed. I'll just erase that right now. That just came with this bit of code. I'm going to explain this in a little bit of detail. First off, we just set the pin mode. The pilot pin is an output. Let's get that out of the way. The pilot pin is an output. That's very basic. This code here I want to explain real quick. Let me pull up something on the web. So what this code does, I got this off the Arduino website. I don't have time to really explain this, but this is AVRC right here is what this is. And it's basically modifying the timer counter registers in the actual microcontroller so that, okay, when by default, Arduino's pulse width modulation, when you use an analog write function, it pulse width modulates at a frequency of 500 hertz. But we need it to pulse width modulate at 1000 hertz or 1 kilohertz. To do that, we actually have to modify the timer counter register and the output compare register in our timer, our second timer. And what that does is it makes it so that our output PWM frequency is 1 kilohertz, essentially is what it does. And it's not exactly 1 kilohertz, it is like 980 or 970 hertz, but it doesn't need to be that spot on. The car is not that picky. Usually, as long as you're like within 1000 kilohertz or 1000 hertz plus or minus 50 hertz, you're okay. So the J1772 standard isn't so spot on that it needs exactly 1000 hertz. You can't even get 1000 hertz out of this microcontroller because of the way the clock dividers and all that stuff work. You can only get so close to 1000 hertz, and we can get within, I think it's like 20 or 30 hertz. This page right here explains it in great detail. This is the actual code that I'm using. This is why I have that pin mode out 11 as an output. But essentially what it does is it modifies timer 2 in the Atmega 328 microcontroller. This will differ depending on what board you're using and what pins you're using. So if you want to just leave out the headache of discovering which timer to modify, I would use an Atmega 328 and use pin 3 or 11 as your pilot pin. If you use pin 3 or 11, you have to modify timer 2, which means you can just copy and paste this code and use that in your project. If you use a different pulse width modulation pin, you have to modify a different timer. And to figure out which timer to modify, you have to go into the data sheet, or maybe you could find it online, and that'll tell you which registers you actually have to modify. So I would stick with these registers, or I would stick with these pins as your actual pilot pins, and that way you can use timer 2 and just modify the output compare registers and timer counter registers on that, and it'll work. It'll work with that pin exactly. You won't have to modify any of this code. So this right here, essentially all this does is it changes the bits in the registers so that your timer your pulse width modulation signal will go from 500 hertz to 1000 hertz. So then the charge request pin, this is the pin that actually monitors. These are the two pins that monitor the pilot line. Remember how I said before they were going to have pull-up resistors? So when we set their pin modes, we set them as not just input, but input pull-up. This enables the pull-up resistor, so they're normally high in all conditions. When the car is plugged in, our comparator will pull it low. So under normal conditions, when the car is not detected, it reads as 5 volts or a logical true. When we plug our car in, the voltage comparator would pull that down to a 0 or a false. It's kind of counterintuitive, I know, but we handle that in the code. Don't worry about it. So the same with the vehicle detect pin. The charge request pin is just monitoring the charge request comparator, and the vehicle detect pin is monitoring the vehicle detect comparator. The power relay is obviously an output, and the 3 LEDs are all outputs. Also very important that we initialize the power relay to low. We don't want it turning on initially. We want to make sure and ensure that it's off when this thing boots up, so we write that as low. Analog write, this is the pulse width modulation. We've already changed the frequency up here to 1 kilohertz, so that's good. Now our analog write for pins 3 and 11 will be in 1 kilohertz. Everywhere else will be 500 hertz still. The pilot pin, so we're going to analog write to the pilot pin, 255. So for those of you guys who don't know, I don't have really much time to explain analog write. Go onto Arduino and it'll explain this very, very well. But essentially what this is doing is it's outputting a pulse width modulation. It's outputting a duty cycle anywhere from 0 to 100%. And to tell it what percent duty cycle to output, we use an 8-bit value. And that value ranges anywhere from 0, representing a 0% duty cycle, to 255. This 255 is the maximum value you can have for 8 bits, and it represents a 100% duty cycle, which is essentially just turning that pin on. Remember, when the charger first boots up, we want to see 12 volts straight DC on that power line, or on that pilot pin, I mean. That pilot pin has to be just straight 12 volts. There's no pulse width modulation at first, it's just 12 volts. So that's what this does. We analog write that pilot pin 255, which is essentially turning the duty cycle up to 100%, or just turning the pilot pin on. And then we turn on the power LED to indicate that LED 1 indicates that all this completed successfully, and it just shows us that we have power on our microcontroller. Okay, so now that's all the setup code. I'm going to skip down to the end to some function I made, and then we'll go into our loop. Our loop is very basic, and then I'll show you guys this quick function that I made. Alright guys, so there's this little function down here called void check status, and I made this because we use it several times throughout our code and I wanted to reuse it. And it's very easy to just make it a function and just call it when we need it. It's kind of self-explanatory. What it does is it checks the status of our pilot pin. It checks to see if the vehicle is connected, and it also checks to see if the vehicle is requesting a charge. So this function right here, what it does is it digital reads the vehicle detect pin. Now the vehicle detect pin, remember, when the vehicle is not connected, it's pulled up to 5 volts, so it's reading as a logical true. Then when the vehicle is connected, it goes to a logical false. So what we do is we negate that, because remember how I said it's kind of backwards? We negate it so that when it's plugged in, it reads out as a true, and when it's not plugged in, it reads as a false. We write that variable to the vehicle detected variable. Remember, this was a Boolean. It was that true false vehicle detected up here. So basically, what this code does is it constantly monitors this pin. Whenever we call this function, it checks this pin to see the state of it, and then we write that to this variable. And if this is true, then the vehicle is detected. If it's false, then the vehicle is not detected. So we do all the negation right here, and we deal with that kind of backwards pin levels. Okay, then this function right here, what it does is checks to see if the charge is, it checks to see if the car is requesting a charge. Now, how it does that is a little bit complex. Remember how I said we're going to have to process this in the software? This is what's going on. I'm going to kind of try and explain it to you guys real quick here. So we have an if statement, and what it does is it uses this Arduino pulse in function. I don't have a lot of time to explain what this does in great detail. Go on the Arduino website. They have excellent documentation, and they'll explain what this means. But basically what we're doing is we're checking the charge request pin okay? And we're looking for a high pulse. This here is a timeout in microseconds. So 5,000 microseconds is 5 milliseconds, okay? So what this is essentially doing is it's looking at that pin and it's looking for pulses. If this pin is pulsing, then the car is not plugged in. I showed this to you guys before in the previous video where I discussed the hardware. Remember, I showed you guys the actual vehicle charge request pin process, and I showed you guys that we have to detect the difference between a 9-volt square wave and a 6-volt square wave. And I showed you guys the outputs of that comparator. In one of the conditions, when the car is not requesting a charge, it's outputting a square wave. So that's what this is doing. It's detecting if there's a square wave. If the car is requesting a charge, then it detects a flat DC wave. It detects it as 0. The comparator is constantly pulling it down to ground, so it's 0. So what this function is essentially doing is looking for that pulse. If it finds a pulse, it will return the value in milliseconds between pulses, or maybe it's microseconds. It doesn't matter. It's returning the amount of time between the pulses. And since we're running at a 1 kilohertz wave, the time between pulses should be roughly 1 millisecond. It's going to be different because it's not actually a square wave, or it's not a square wave, but it's not 50% duty cycle. The duty cycle varies by a little bit. So that just depends on what duty cycle you run, but we're waiting 5 milliseconds, so that's more than enough time. If it doesn't see a pulse within 5 milliseconds, for sure that wave is flat and the vehicle is requesting a charge. So if it doesn't see a pulse within 5 milliseconds, it returns 0. So essentially what happens is if it's greater than 0, if this function returns something greater than 0, then it's getting pulses and the vehicle is not requesting a charge. Therefore, charge requested is false. Otherwise, if it doesn't see any pulses, this function right here is going to return 0, and it's not greater than 0, it's equal to 0. So we jump to the else statement, which says the charge requested is true. That means the car is requesting a charge. So each time we call this function, it's basically analyzing these two pins and setting these two variables. So it'll update our vehicle detected variable and our charge requested variable. So all this function does is check the pins and updates our variables depending on what is actually happening on the pilot pin line. Now, if we go back to our loop, this is what's going to loop the entire time. So as soon as our microcontroller is booted and it's done all the setup code, it loops. So the first thing we do is we check our pins. We see if it detects the car. We check the status. That's what we do very first thing. And basically then here's all the conditions. This is what happens. If the vehicle detected is true, so if the vehicle is detected, we digital write our LED to high. This is that LED that tells that the car is plugged in. So if it detects that the car is plugged in, write that LED high. Also, we're going to write a square wave, or not a square wave, but it's a square wave, but it's a pulse width modulation. So we're going to pulse width modulate our pilot pin now. So as soon as we detect that the vehicle is plugged in, we're going to turn on the LED and we're going to turn on our square wave. So that pilot signal is now has a square wave on it. It has that pulse width modulation. The duty cycle here, I will explain this later on. You might not use 64. I'll explain the duty cycle in a little bit at the very end. But so if we detect that the vehicle is plugged in, we're going to turn on that LED, and then we're going to analog write our pilot pin. Else, if it's not detected, we're going to turn the vehicle detected LED off, and we are going to then turn our pilot pin back up to a straight DC signal. We're going to turn it to 100% duty cycle, and we're going to go back to that idle state where we wait to be plugged back in. That's what that does. So this just handles the pilot pin pulse width modulation and to detect if the car is plugged in. Okay. Then what this statement does is it says if the vehicle is detected, and it's very important that you do it this way. You can't just check one of these. You have to check both of them. If the vehicle is detected and the charge is requested, if they're both true, then what we're going to do is I have this little bit of code kind of like this adds a little bit of security to it, kind of helps it it's kind of like a little debouncing circuit, or like a button debouncer, but or like a button debouncing software, and it just checks to make sure that the car really truly is requesting a charge, because it's possible that you could get some noise on that pin or something, And if it detects noise just for 1 second or just for like a split second, it might activate our power relay, which we don't want to happen. So what I'm going to do is I'm going to check to see if the vehicle is detected and the charge is requested. If this is true, then I'm going to wait 1 second. I'm going to wait 1 second, then I'm going to check one more time. I'm going to update our pins. So I'm going to check the status of the pins one more time. If after 1 second it still reads true, if the vehicle is detected and the charge is still requested after 1 second, then I'm going to assume that the car really is requesting a charge. So I'm going to check it twice. I'm going to check it once, I'm going to wait 1 second, update our pins, and check one more time that the car truly is requesting a charge. If it's requesting a charge, I'm going to turn on our charge LED and I'm going to turn on our power relay. We're going to turn both of those high. This actually gives power to the car. So we check it twice because we don't want that power relay to be enabled unless it truly is requesting a charge. We don't want any noise interference to enable this power relay. So we check it twice, once after another second. And then else, if that's not true, what we want to do is write our power LED low and write our power LED low. This is for the second check and this one's for the first check. So if after the first check, if it checks it once and this stuff is not true, we're immediately just going to say the power LED is low and our power relay is low. If it's true, what we do is we check it one more time after a second, and if it's true that time, then we turn it on high. We turn both those things high, and if it's not true after a second, then we keep them low. So this is, it double checks it just to make sure before we turn on our power relay, it checks it twice. And that's pretty much all the code. There's not really anything else to it. Like I said, it's not very rock solid, but it's good enough to get your car charging, and it does actually work. Like I said, I really wish I could have kind of gone back and forth between as I developed this code and showed you guys the progress on the board. But like I said, I was an idiot and I didn't check the polarity on that board and I fried the board. But I'm really, really happy that I already got the footage of this code working, and I got it working so that I don't have to fix that damn Arduino Nano and desolder that thing off the board. So in a second, I'll show you guys some footage of this actual code running on the board, and we'll see the board working with my car. But for now, I want to go ahead and go back to this duty cycle and explain this real quick in a little bit of detail. All right, guys, so let's go ahead and explain this number right here. What this does is, I explained before what the actual pulse width modulation does. It tells the car how much power it can draw. So when we detect that the car is plugged in, we turn on our LED to indicate that the car has been detected, and we also begin to pulse width modulate our pin at a specific duty cycle. Remember before I showed you guys, we kind of saw that table that showed that. I'm going to bring that in right here. This is the Wikipedia page. Let me see if I can kind of, I can't really, I don't know if I can mirror them because I have a dual monitor setup going on here. But anyways, I'll kind of leave it off to the side here. If we have it right here, this shows right here the corresponding, the pulse width modulation duty cycle corresponding to the actual current. So you guys should put whatever number you want in here depending on what current you want. For me, I want my current to go to 30 amps. I want my charger to max out at 30 amps. Okay, and it won't hurt if you put more than your car can take. If your car only takes 30 amps, it won't hurt if you give it, a higher duty cycle. If you give it like an 80 amp charge, all that'll happen is your car just won't take the charge, or not that it won't take the charge, but it'll only take as much as it needs. It's not like you're gonna overpower your car or anything. If you put a larger duty cycle than your car charger can handle, all your car charger is going to do is go to its max capabilities. It's not going to go any further than that, so you won't do any damage. And if you go to a lower duty cycle, it will limit the current at that duty cycle. So if you want your charger to only run at 15 amps, you want a 25% pulse width modulation duty cycle. Okay, so what this number means is, like I said, it scales. The duty cycle is between 0 and 100%, and the 8-bit value is between 0 and 255. So if we wanted a 50% duty cycle, what we would have to do is go halfway between 0 and 255. That number would be 128. Okay, I know you can't go exactly between 0 and 255, but 128 is you can think of it as between 0 and 256, because I don't want to explain how that works right now. That's way too complicated why it stops at 255. But basically 128 is a 50% duty cycle. So if you want, where the hell did that go? If you wanted your charger to charge at 30 amps, you would put 128 in here. If you want it to charge at a specific current, and also another thing I should say is you don't have to use these exact duty cycles. It's kind of like linear. You can go in between these. You can choose a 35% duty cycle. You can choose values in between these, and it'll vary your current in between these values. It doesn't have to be spot on. It's not like these are set values and you have to use these values. You can go anywhere from 10% up to 50% and everywhere in between there. It doesn't really matter. It'll vary the current anywhere in between there. So this is just kind of like a handy reference if you want to know kind of some ranges. So let's say we wanted a 30% duty cycle. It's very easy to see that 128 is a 50% duty cycle, but if we wanted to charge at 18 amps, how would we know what would give us 30% duty cycle? And I'll show you guys how to do that right now. It's very easy. All you need to do is just get a calculator and multiply 255 times whatever percent you want. So you have to convert the percent to a decimal first. So like for instance, us for 50%, we'd multiply it times 0.5, and that gives us 127.5, rounded up to the nearest whole number. So we round it up to 128. If you wanted a 30% duty cycle, we could say 255 times 0.3, and that gives us 77. So we'd put a 77 in here. So if I put in a 77, what this would do is it would charge us, why do I keep clicking that? I'm going to get rid of that. It would charge us at 18 amps. So we would be at a 30% duty cycle, and that would give us an 18 amp charge. If we just wanted a slow charge, we could put in a 10%. That would obviously just be like 26. So you just put in 26. That would charge you at a 10% duty cycle or at 6 amps. So it'd be really slow. So you can put whatever number you want in here to modify your duty cycle and your charge rate. And you could also do what I did in my previous video. If you go way back to where I showed you guys a charger originally, I had buttons where I could change this. And all I did was I had buttons that would increment this number, and that would allow me to change the actual charge rate of the car. And I could change it, I think, in increments of, I don't even know how many amps, but I could change it in pretty fine increments. And I could go anywhere from 2400 watts up to 7200 watts charge rate. So that's how I did that. I just had some buttons built in my Arduino where I pushed them and they would actually modify this number right here. It was a variable, and I would modify that variable based on some little algorithm I made. But I would recommend just putting in, like, you know, whatever charge rate you want. If you want a 30 amp charger, that's probably as fast as most cars will charge, you do 128. One thing I want to say you got to be very, very careful of. If you go, make sure that all your hardware is compatible with whatever charge rate you put in here, okay? If you have a Tesla and you charge it at, like, let's say 80 amps, and you are using 30 amp wiring, you're using a 30 amp relay, you're using 10 gauge wiring, all your shit's rated for 30 amps, your car will start to pull 80 amps, and it will fry everything. Your wiring will melt, your relay will melt, everything will melt. So ensure that whatever duty cycle you set here is not rated above what your actual hardware is capable of handling. Also, make sure that your breaker, most importantly, make sure that the circuit breaker you install is rated for whatever duty cycle you put in here. So even if you do have, let's say you accidentally put in the wrong number in here and you put it up to 80 amps and you have a Tesla and you're charging at 80 amps, if all your hardware is rated for 30 amps and you have a 30 amp circuit breaker, your circuit breaker will just trip. That's all that'll happen. But if you have like a 100 amp circuit breaker and all your shit's rated for 30 amps and everything, and then you go and put an 80 amp value in here, it will have a meltdown. I'm just telling you guys right now. Make sure that whatever value you put in here corresponds to the capabilities of your hardware. I'm not saying you can't build an 80 amp charger. You damn well can, but make sure that everything is rated for that, okay? Also, guys, I almost forgot to show you guys this. I wanted to show you guys this. I drew it last night, and I totally forgot about it, but I wanted to show you this real quick. This is just kind of the mains wiring. I wanted to show you guys how it's done because I didn't actually show you guys this in the other schematic. The other schematic was just all like the low voltage hardware, but this is your relay, okay? And this is the relay. One side goes to 12 volts, the other side goes to that MOSFET. the MOSFET drain. That was that pin on the board. So that's how the relay coil is hooked up. And then here's essentially what happens. Your two big wires, the power wires, one will be black and one will be white, or one will be black and one will be red. It doesn't really matter. In your J1772 cable, those two wires go to each pole of this relay. So this is a double pole relay. Your relay has to be a double pole relay. I'll say that again, the relay has to be double pole. You don't want a single pole relay because then one of your phases will always be connected. You have to have a double pole relay. I recommend just using the part that I showed you guys earlier in the hardware setup. I zoomed in on the part number. It's a really good part. It hasn't overheated. It hasn't given me any bullshit, no problems so far. It works good. So this is the actual relay. When you energize this coil, it closes both of them, and that makes your two hot phase connections. This so this side, one side of the relay goes to your J1772 cabling, and the other side goes in the wiring, which should run down a conduit and into your main panel. That goes to a 30 amp or appropriately sized breaker, depending on what size charger you're making. It could be a 15 amp, it could be all the way up to 80 amps. If you're going to make an 80 amp charger, you probably just use a 100 amp breaker. And you have to use the appropriate size wiring. I'm not going to give you guys a lesson on wiring sizes right now. I'm assuming you guys kind of already know that stuff. Just real quick, if you're using 30 amp wire or 30 amp breakers, you're going to use number 10 wiring. That varies between county to county, state to state. It's different everywhere, but for the most part, it's usually the same. I'm not going to tell you guys the wiring sizes right now. That's out of the scope of this video. On the other side of the 30 amp breaker will just be, your main AC bus bars, and that'll give you your 240 volts AC. So you have 240 volts AC, 120 leg here, 120 leg here. That goes to your 2-pole breaker. 1 pole of each breaker goes into the input of your relay. The output goes to your J1772 cable, and it doesn't really matter which side is your input, which is your output. The relay might say, if it doesn't say, it doesn't really matter. Just make sure that you don't hook it up the wrong way. Make damn sure that when you hook up your relay, you have it hooked up the right way. It will make a difference, and as soon as you turn it on, the entire thing will blow up and it'll blow your breaker instantly. Make sure that one side of the one hot leg goes through the relay to your J1772, and the other side goes to through the relay to your J1772. If you take these two wires and you hook them up across this, as soon as you energize your coil, it's gonna touch your two hot phases together and blow up. And it'll most likely trip your breaker and just cause a bunch of sparks and damage your relay. That relay was kind of expensive. It's not one I would want to damage, so make sure you hook it up the right way. Do a continuity test across these just to make sure. Energize your coil, do a continuity test, make sure everything's good before you hook all this up. Your ground will go from your panel straight through to your J1772 cable. I show you guys that in the actual hardware. I'll show you guys again when I show you guys up close of the hardware of this board when I have it plugged in, but this is the ground. Also, make sure that your 12 volt power supply, one of them, it goes up to 12 volt, and that just goes all to your 12, everything that was 12 volt in the schematic gets connected to the 12 volt side of your power supply, and also the negative side of your power supply goes to everything that needs to have the negative side of the power supply, and very important, it goes connected to ground. Your negative side of your power supply has to be connected to ground. I will say that again when I show you guys this thing actually working. I'll say it like twice. Your negative side of your power supply has to be ground. So your power supply is negative grounded. Also, this isn't really the symbol for power supply, it's the symbol for battery. I know, just bear with it. So I just wanted to show you guys this real quick. I didn't want to leave you in the dark as to how this is all wired up. It's very simple, but it's very, very important that you wire this up right. Alright guys, so just to prove to you guys that this thing is working, here's the power coming in here. I do not recommend doing it this way at all. This is just a temporary, quick little setup here. I just wanted to get it hooked up to power. I got some pictures of how that's wired up, so I will show you guys that in the end, but I didn't want to actually film it while I was wiring it up. So we got 3 10-gauge wires right here, the ground and the 2 phases. And they're coming in just as before. This is the same thing as before. On the last video you actually saw the conduit in here, but like I said, it's been unhooked for a while, and I actually don't have that piece of conduit here anymore, so I didn't want to go down to the store and get any. That's why I just wired it up like this. So do not do it like this. This isn't the right way to do it. So we are going into the power supply right here. As you can tell, I've unhooked a few things from here. There's not too much hooked up. So none of this is really hooked up. I just wanted to use this enclosure so I didn't have to, you know, redo anything. So here's the power supply. It's actually live right now. Everything's live. So the 240's on. The supply is energized. I actually have it hooked up to the car right now, and it's charging. But I'll unhook the car actually real quick, so you can hear that power relay click. None of the LCD or anything is hooked up again. None of this is even powered on. This is not being used at all. So we have our 12 volts coming in here, going into that power side, just like that. So there's our 12 volts. And it's very important also, here's the ground wire going into the J1772 plug. Here's the ground wire coming from the actual panel box. It's very important that you take the negative side of your power supply. That's what's going on right here. And it's going up into this and coming back to here, to this ground bar. The negative of your power supply has to be grounded to this ground bar, or else it will not work. I'll tell you guys that again. If you do not have your negative side, if your negative side of your power supply is not grounded, it will not work. I actually didn't hook it up at first, and I was sitting here troubleshooting it for like a few minutes, wondering what the hell is going on. It was acting really funky. You have to have your negative side grounded, okay? So just to get that out of the way. If it's behaving like really wacky, that's probably the issue. Then this is the pilot wire going to the J1772 cable down there. That's going into our pilot port on our board. And then the relay has its one side. This orange wire goes straight into the power supply to the 12 volts, and the black wire goes into our port on the board, which goes to the drain of our N-channel MOSFET. So, and it's all hooked up here. You can see it's actually powered on. So our status LEDs, we have the one, so it's ready to go, but it's not actually plugged in yet. So I have the cable right here. There is the car. It's not charging yet, so I'm going to plug it in, and we'll look at the status lights. Alright guys, so there's the LEDs. I'm going to plug in the car now. You'll hear it. You can see it registers that. The car's relay's clicking, and our relay clicks in with that little delay. Remember, it does that check twice. So the car is now charging, as you can tell, and there's no Photoshop magic going on here, just so I don't get any heat for it. Here is the cable going into the car. It's going straight into this mess of crap right onto the wall right there to our charger. So there's not like, we're not doing any magic here. It's not like I'm trying to rig together multiple shots to make it look like it's working. I don't know what the whole point of this video would be if I did that, but anyways, we'll unplug it. The relay clicks off instantaneously. Plug it back in. It registers that it's plugged in. Gives it a second, and it clicks on. And notice you didn't hear the car relay click on that time. That's because the car relay stays closed for a certain amount of time, maybe like 5 minutes or a little bit less than that. So the car relay stays closed for a little bit of time after we unplug it. If we waited a little bit longer, the car relay would then open, and then when we plugged it back in, it would close again. But that's why only our relay clicked. And then I'm going to unplug it, and almost instantaneously, that relay will click off. Alright guys, just real quick, I just want to show you this. This is not the right way to do it. Again, it's just a temporary little setup. But the 3 lines are coming in here. The ground is going right into the ground bar back there. So this is our ground. Goes straight back into there, nothing fancy. And then the 2 hots go all the way up to this 30 amp breaker, which is off right now. Those are the 2 hot phases going right into there. So, and that's the entire panel. So there's nothing fancy going on there. Alright guys, that pretty much wraps it up for this one. I'm really happy I got that board working and actually running before I fried it. That would really suck if I had to fix that thing in order to finish the series. That would not be fun. I don't want to desolder that Nano. It has like 40 pins on it or something ridiculous like that. Like, I don't want to do that. But that's pretty much it for this one. If there's anything that's unclear, please leave a comment down below. If you guys aren't very clear on any of the code or how I wired it up, the video I showed of me actually running it into the panel was very brief, but I'm assuming you guys already kind of know how to wire it up. It's very basic, just the 2 hot phases into your breaker. And I have a whole nother video on my channel that kind of shows an actual electrical panel broken down, like actually in my room. I kind of explain how it operates and all the technicalities behind the home distribution power system. If you guys are really interested in that, go ahead and watch it. It might help you as far as wiring up that as far as wiring up the car charger. It'll definitely help, I think, if you're not very familiar with that stuff. It'll get you comfortable working in that 240 panel. But yeah, I definitely would recommend checking out that video too. Alright guys, so that pretty much wraps up for this one. I mean, if there's anything that was very unclear or that you didn't understand, please leave them in a comment down below and I'll try and address it. Hopefully it doesn't require me to fix that board in order to explain it, but if there's anything that was really significant that I might have missed, I'll make an entirely different video and there will be like a part 4 to this if it's that major. If it's something small that maybe you're just not understanding, or that I feel that it's not that major, I will just leave a comment and reply to you, and just that'll be it. But for the most part, I think I covered everything. So alright guys, that pretty much wraps up for this one. I'd love to hear you guys' feedback, and as always guys, have a good one.